Good morning and once again welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video I want us to explain example 6 in shape and space 8, whereby we have in triangle OAB, the midpoint of AB is M, the midpoint of AB is M. OA is X, as you can see, OA is X, OB is Y, OB is Y, and OD is 2x, so it means even this part is just x. AD is x. If from O to D is 2x and this OA is x, it means AD is also x. And likewise, it happens in the same way that OB is y and OC is 2y, meaning this part is also y, BC is y. Part A of the question, express AB, OM, DC. Let us have AB, vector AB in terms of x and y. Vector AB is basically you walk from A to O. This is AO plus OB, and AO is simply negative x. This is negative x because of the opposite direction of x plus y. That is it. You can basically say y minus x. And that is AB. What about OM? Vector OM. Vector OM is OA plus AM. And we all know that OA is x and AM is a half of AB plus a half of AB. Incidentally, AB happens to be y minus x. So we are going to talk about x plus a half of y minus x. And this will give us x plus a half y minus a half x. Everything now collecting the like terms, x minus a half x is a half x. So it's a half x plus a half y. That is vector OM. What about vector DC? What about vector DC? Let's see. DC is you have to walk from D to O, opposite direction of the whole stretch, which is 2x. So minus is actually DO plus OC, which is negative 2x plus 2y. You may say 2y minus 2x. That is DC for you. And that is just part A of the question. Part B of the question, what do these results show about vector A, B, and DC? What do these results show about vector A, B, and DC? We have to highlight them. Vector AB is y minus x, and vector DC is 2y minus 2x. And clearly you can see when you compare the two, you can see that twice vector AB is equals to vector DC. So we can say twice of vector AB is equals to vector DC. Because as you can see, if you multiply y minus x by 2, you will simply get 2y minus x, which is basically 2y minus 2x, which is the vector DC as illustrated below. So this is clear. What does that mean and what does that show? It shows very clearly that now that we are able to express vector AB as a scalar multiple of vector DC, the two vectors AB and DC are parallel or must be parallel. When we say expressing them as a scalar multiple of each other, we want to mean that one vector can numerically be explained to be equals to the other vector. Scalar multiple. It is a multiple of each other. And that scalar can be a whole number, it can be a fraction, it can be anything. But so long as the two vectors can be expressed in terms of one another, that is how we say we are expressing the vectors as scalar multiple of each other. And this is our conclusion. Now that we can see vectors A, B, and DC are expressed as scalar multiples of each other, then AB vector is parallel to vector DC. And don't forget, even DC can be expressed as a scalar multiple of each other. We just need to divide both sides by 2. And I may want to put it across here. Now that 2AB is equals to DC, then AB can also be equals to a half DC. This can also be expressed, and it continues to mean that the two vectors are parallel. And that is it. Thank you, and let us meet in the next video.